this is Koiro with another video, and this is another one where I tackled C64 stuff, and actually it's my 7th video since I took up this this lot with C64 stuff that I bought a while ago. And last time we did start with this board. It's a 425 board with a lot of issues, and this is the board where we tested all the different 373 chips. And for those of you who missed that, there is a link in the description below. But this is a 425 board, and it's really bad quality. The PCB, it's what I will call rotten. The pads are getting loose for, you don't have to heat them almost at all before they fell off. And last time I thought it was the previous owner of this board that had done some bad soldering, but in this video I did desolder some more chips, and on the middle of the board it has really bad quality, but on the edges of the board I didn't have this much problems, so it's not good. And I have made this board overall in a bad, much worse condition than it was when I got it, because I had some issues that needed to be tackled, and I couldn't manage to keep this board in better quality than this. So this might be ought to be my new scrap board, but I'm going to fix it anyway, so that I know that everything that is on this board actually is working if I'm going to scrap it later. And I'm also in this video going to go through another one of the things that was in my lot with C64 stuff, and this is the ChipTesterPro. And I will start with going through this in this video. So this will be an interesting video, I think. I hope you stick with me till the end. Even though there are some boring parts and some interesting parts, I do think there is a lot to learn in this video, both about my mistakes and the methods that I've used here and the tools that I use. So back to the bench, and we will get on cracking with today's episode. I do have a lot of stuff to do fault finding on old computers. I've recently taken up of using this logic probe more, and of course I have the multimeter, and I also use this to test old chips. I had this for some years, and I had some other burners before that. And I do have this one. This is the Retro ChipTesterPro. It's a very good and capable device. It's a bit troublesome to do firmware upgrades and stuff, and it does have one slight disadvantage, and this too. You can of course test ROM chips, RAM chips and logic chips on both of these, but you can't test the Commodore custom chips. And that's a drawback that I had for some while, and when I bought this huge lot with stuff, this one was included. And this is the Backbit ChipTesterPro. It's not the Retro ChipTesterPro. This is more, let's say, up to date. It's also testing some newer chips. It does have some limitation, of course. And I don't know if this has been used. I don't think it looked used. It's the serial number 384. And there is a version 2 of this, and I believe there is a version 3 on the way, but at least there is a version 2. And in the box you have some loose chip testing wires and stuff. I don't know if this has ever been used. This has been opened before. I have opened it before myself, and I don't know, as I said, if it has been used or not, because this was still with the original wrapper on the display, and it also has an unopened USB cable, and this is not a normal cable, it's the one with the type A connector in both ends. And that's it for what's in this box. And we do have this trouble with this VIC-2 chip, and I do have some troubles with some CIA chips. So I was thinking, why not put this to the test? And I have not checked yet, but we got some tip that it might be a faulted PLA chip that was causing this mishap with all these 74373 circuits in my last video. But let's see if we can get this one working and see what it's capable of. So I will try to connect this up, see if there is some firmware to this, and some software. Please read online documentation carefully and follow tutorial. Backbit downloads. Operating chip tester on live electronics may cause damage to device. Yeah, unplug all devices. Yeah, and there's a forum. But chip testing in circuit testing. Let's see what it says here. Yeah, firmware upgrade. You have to place a file in a FAT32 SD and plug in, so there is a SD socket here. Yeah, there it is. It's room for an SD card, and you do have a row here for plugging in extensions, and you do have a 48, and this is okay. So this is I do think this is the normal closed kind of socket. They are more reliable normally because you have a harder spring action. Yeah, and this is some 3D printed stuff. This frame and this, but it looks quite good, and it's, I do believe I was trying to find out if I have done something wrong with not buying the V2, but I do think there is not many differences at all. At least I do think it's the same firmware on both, and also I do think this is different if I can take this from just looking at pictures. But there is nothing said about software here, so I do think everything is controlled on this device and that there is no PC option and stuff. So let's log into the Backbit web page and see what they got going there. Yes, I'm logged into the Backbit. It seems like they have a IO address web page, and it's quite the simple page, but they do probably have what they need. They have the forum, and I just registered for a user there, and I have the downloads, and that's it about. But I was hoping to find, okay, there it is. You do have docs and chip tester, and okay, so this is it, and this is updated of April 4, 2024. Summary of features, USB cable, firmware upgrade, and this was what we were looking for. And this is the same, it's the same page that we was in, but it was the firmware, not the docs. And you need FAT32 formatted SD card, and that I have a card that I used for something else here, and it's a 64 gigabyte card, but I did make a 16 gig partition to it so that I formatted it as FAT32. I will just put that in here, and insert card and power cycle the tester. Yeah, that seems about right. This is the default test mode, and they have the knobs here. Yeah, normal mode, burn-in mode, offset mode. This is the default test mode. We confirm to that as of now. passed or failed, test categories. And here we are seeing what I going to use it for just now. And yeah, you can dump some stuff with this thing, and it says what is defined as high and low voltages. Yeah, it does have some limitation, I think, in this, but it's full of the normal TTL values, at least here about. But I wonder what they do with 3 volt logic. Corn bit, that has to be some extension thing. DRAM adapters, yeah, so this is and the advice for the forum. And that's it for the documentation. And chip tester, firmware, yeah, they have some, and they have done a large revision here. I will just download a couple of these and have them ready. I do wonder if I go back here to the document here, what it did say about insert card and power cycle the tester. Upon successful firmware upgrade, the file will be erased. Yeah, okay, so I can only put one file at a time on the card. And yeah, I think we go back to the bench and power this thing up and see what happens. Yeah, so now we're back at the bench. Oh, it was a very harsh light on this. There is something about this auto expose feature on these cams that I can't comprehend, so I do have to adjust this. Yeah, I think that's a bit better. Let's just open this one. I hate when they do these plastic things. At least it was not the stiff plastic that is used on food and other things. That's always an annoyance, and it cut a hole in the garbage bags and so on. They said that it needed a dedicated, or it's not dedicated, but they preferred a 2 amp power supply. But I do have USB hub with a dedicated power supply here, so I will just test that. And there is no power knob, so I don't know if you will be able to see this. If I turn off the overhead light, yeah, that actually don't look too bad. And it says something about version 1.49 2022, so this has been lying for some time. And let's just turn it off, or we can see what happens here. Main menu, mouse, Sega specific. Oh, here they have the PLA, MMU. This is for the and you have some other PLAs, 1571 gate, 5041 gate, another PLA, and they have the SID chip, 8580 SID, the 8701 clock chip, VIC2, VDC, yeah, the other variants of the VIC2, the 9 volt chips, ACIA, 85 the Amiga, and 8502. Yeah, they do have a lot of stuff in here, but let's disconnect this, and I'm just going to just quickly copy this to my card. And this is a USB adapter, and let's see if it will swallow this one. Which way does it? Yeah, it was a bit, but I think it's in there. Let's see what's happening when I turn on the power, or not turn on, but plug in. Oh, it's already upgraded. It now says 2024 and I did the 4.2 version. Let's see if there is some mouse, computer, buster. Yeah, it's a lot more here now. It's 52 versions in here now. And I will just take this out and I'm going to put in the latest firmware. I did this only as a test, but I also downloaded the 5.00 version. So let's quickly put that on the card. Why doesn't this register? Okay, there it comes. This adapter thing is not always the best way to do things. Yes, and then it comes version 25 something. Yeah, but it's still stated 2024, but this BIOS is from, I think it was February. I'm not sure. I did see some dates on the screen here. Maybe it was March. So this should be the latest version. And let's see if they have added some chips here. No, it's still 52. But then we do have a working tester, hopefully, probably. So we can of course use this to test our PLA. We did have this this PLA chip that we have used now several times that does have a defect in one bit on a port. Probably it's in here. Yes. There, 6526 CIA and test. Did it register? We have to choose it first. Oh, place minus jumper at position 1. That's maybe what we need to use these things for. This is a minus and position 1. Can't verify minus. Place minus jumper at position 1. And this is clearly marked minus. Maybe I should do this with things turned off. Minus position 1. Like this. I wonder why this is happening. Okay, place plus jumper. So you should not have the chip in. Of course, I now used a red wire for the minus. At position 20. Ready to test. Okay, there it's testing. Normal mode. And that is just testing once, I think. Failed one test. Yeah, we know this was faulty, so okay. If I take this out, and what if we test the JCIA chip? It's quite the expensive thing to just do a test with, but oh, it also failed. I'm not very convinced so far. I do go and get some other chips. What other chips do I have here laying around? Let's see. Do we have some of the ROM chips here? I do have the VIC2 chips. I do have the C65, 69, and I do have a ROM chip here, and I also have the Plankton PLA. Here you have the VIC2 chip test, and these chips has been confirmed to working. If I shows this, can't verify, remove minus virus. Place minus wire at position 20, like so. Plus wire at 48 and 13. Like so. Ready to test. Passed PAL. So this actually works, but I don't remember if I actually tested this JCIA, so it might be faulty, but we will have an opportunity to test it on the board that we are working on now. At least we get a partial result here. But I will need to test this with another CIA to check what's going on there. But it didn't have the ROM chips. Let's see, I didn't remember on the top of my head what was the C64 PLA. It's the 906114. This PLA here, and let's test with the Plankton and see how that goes. Okay, place minus jumper. At 14 and 48. Ready to test. Okay, this is made like so. Okay, so it should be like so. And it passed. So at least it can do something. Yeah, but we don't have the ROM chips here. Maybe if I go to, it's strange that they are not here, ROM and ripping. And here we do have some PAL chips. You do have the, for ripping the kernel and the basic, but there is no testing as far as I can see. It's better to turn it off so I don't burn my PLA here. Okay, I need to verify this with another CIA chip that I know is working. And here I have a working CIA. This one was thoroughly tested. And it's a desoldered chip. And if we just power this up again, and say that we are MOS, and we are going CIA, and this is CIA minus jumper at position 1 and 20 for the positive jumper. Like so, ready to test. Yeah, so this passed all tests. So we do know that at least it's working, and there is something other triggering this other JCIA to not work. So I'm just going to pull them back here. And this one, let's just keep it here till we have the board on the bench. Then we have to do some desoldering to have something to work on. And this was the board that we was working on last time. And we did encounter that it had a bad CIA, and we also did encounter that it had some other issues. This is the board in question. Yeah, so what are we going to do here now? I'm going to have to desolder this one, and also I got a tip that it could be the PLA. And the issues we were having was that we were having artifacts on the screen, and it did depend on this one. So just to make sure that everything is working, we can connect this to power. Make sure it's turned off. Power and the video, and hopefully I will be able to get a good capture. Yes, you can see this has some artifacts on screen, and this is actually the HC version that is standing in now. I don't remember what was our last conclusion on this, but sorry for the whining noise in the background. I seems to can do nothing right when it comes to capture. This is my Legato capturing device that is capturing the sound that comes from the C64 as noise, and it's mixing it into the sound, and I can't filter it away. Sorry about that. Yeah, and the keyboard bad, and CIA bad. Oh, it actually do have some other artifacts than it did have the last time we tested. Pretty strange, but let's just give this a test and try to swap this one and see what actually happens. Yeah, now we have the other blurry thing. So things are happening about as they were. Oh, now you can see it actually calmed down a bit. I try to turn it on and off. And then you get this one. This is what made me think that it was the Moss ship, the Victor ship. Let's see if it corrects itself. Yeah, and I also have the SID chip in. I normally don't do that when I test, but this probably sounded totally horrible because I did have on both the sound on the capturing device and on the open mic, so I'm not sure how that sounded, but we need to get some things done here. And what we know from before is that this motherboard, this main board was a total disaster, and we will be able to check now if it was the quality of the PCB or if there was some bad soldering done on this board from before, because a lot of the pads was loose. And I did manage to fix up all that, I think, but there is no way to be absolutely sure. So it's this one that needs to be desoldered, and I'm just going to fire up my desoldering gun. I did a lot of cleaning on this last time, so hopefully I won't have to do that again. It might be a bit clogged. Let's try again. Yeah, I cleaned out most of that pretty well. And the trick is to do the circular movements to free the pin, and also these pins have bent legs. Normally with the desoldering gun on this I do use like 350, 370 degrees, but on this board I had to use about 400 degrees to actually melt the tin at all. And I don't know if it would have made a difference at this point if I made some mixing with normal leaded solder on this, because it seems to melt rather slowly. Yeah, most of the holes went okay, I think. This ground pin did not. But we might have to do some hot air action here. Just check on this side. Yeah, this is definitely some hot air needed here. And just use this to put some pressure on it, and this was a stubborn one. Yeah, this is insane. I have never had to use this much heat to desolder a chip on a C64 before. So this board, it's some crap. Because on a 407 board, especially the pre-tinned ones, the chip would have fallen out. To put this in some kind of perspective, I'm showing this now with 300% speed increase 3 times, and I have not cut away anything. And normally when I do the desoldering of chips with the desoldering, not the desoldering station but the hot air station, I use 20 degrees colder air than this, and the chips are falling out after maximum 20 seconds. No wonder that the previous user had lifted some pad when he had done the desoldering. This was the most stubborn chip I've seen in a very long while. And I do wonder if this was earlier than lead-free solder, but this actually acted like lead-free solder to me. We do have to clean up some of the holes before we do anything else. Just use some water on the sponge on the soldering station. Use this needle to try to heat and get the punch through on this hole. This is the ground plane. It was the most stubborn one, and it did not melt at all until the very last heating. That side, and just on the other side it actually looks quite okay. Now I'm clogging up the hole for the ground plane again. Let's just put a socket in here and take it from there. And before we do that, we are going to grab our chip tester again, and we are going to test this chip. And the last thing I tested was a CIA, so probably that should be okay with the pins. I mean the power pins. Ready to test, so it was okay to test. We can't detect the pin correctly when the chip is in place. Passed all tests, and we have to remember this actually tested an error on our tests, and I do wonder if I can blame the diodes for this time. I'm not really sure, but we have to put in a socket anyway and see what we need to do with this, because this CIA, it tests totally fine here, but the testing harness told us otherwise. So this is okay. So, still confused, but we do have to dig deeper. getting a bit messy on the bench, but I think I will manage. And I will just put in this socket. This is a normal dual wipe kind of socket thingy. And let's see if I can get it through the holes that was not totally. Yeah, I think I do. This is so if they meet any resistance, they will pull up the socket wipes, contact points. Yeah, but it fits okay. And this chip that we have here, it's still in this. Oh, sorry. It's still in this retro tester. Now it's desoldered, and it had very short legs. So we should have had some of these, machined round hole sockets. And of course I can mix that. I can use some sockets and just mimic this. I can use, I do have 20 pins and 18 and 16 pin sockets, and I could have broken them off and placed them in here, but it would not look rather good, and I'm just going to put this right back in, I think. And this board is getting kind of ugly anyway because of the repairs we had to do, but we do have done quite a good job of cleaning this out. So I do think this board is really worth saving, and I will desolder these diodes too and check, and I will also place this back in the socket and check with the diagnostics before I do anything else, so that we are sure that this is in the same state as it was before we did anything with this. So I'm just real quick going to solder the socket in. Yeah, like so. So, okay, yeah, I think it's good enough. Maybe a little unfilled some of this, but I do think it's okay. And I'm going to try to wrestle this chip back in. And I might have to do some cleaning of some of the legs here, because you can see here there are some solder stuck here among some pins. Yeah, that the legs are thinned or a thin layer of solder is not a problem, but if there is any sharp edges to the solder, then it will rip the socket legs or the swipes out when you put in the chips and take it out. Yeah, at least that is cleaned. And I do have some pin straightener thingy, but it's not good on these pins that has been soldered before. Like so. And will we be able to fit this in a socket? Yeah, a socket is normally a tiny bit narrower than the holes in the PCB. Yeah, it has to do with how the swipes are made in the socket. So we do sometimes have to adjust the legs, and this is the best way to do it in my experience. Yeah, let's try. See where we get. Like so. Yeah, both me and my son that is also in this room, he has also got a cold, so he's also coughs a bit. And we have to connect the video. It goes on here. And the power, a blue power supply, turn on capturing. Okay, so now you have this issue that we had several times, but let's first set this to diagnostic and like so. Yeah, we have several states that is. Yeah, just to be clear, the color distorted picture is my AV to HDMI converter that's detecting the signal as CCAM. It's not a fault with the C64. We just have to run this check through. I'm going to try to turn off the audio. Yeah, audio on the TV set that is showing me the picture. Yeah, it still gives bad keyboard. And actually it kind of hung the machine. Yeah, it is. The test actually did not complete. I will try real fast just to desolder this diode. So that is here. We'll just lift them up on one side. Like so, and I will also check beneath the keyboard connector if there is some bad soldering. It's not. Yeah. Plug this in again. I can leave the board and let it run through and check if everything is okay. No, it came out the same way. Yeah, as we can see here, the fault is not consistent. We do have some intermittence here in this, and someone gave me a tip that I could check the PLA, that it could be almost faulty, and I might think we have to dig into that and desolder it. Why don't give that a test? I do have these Plankton's PLA. I think this was Plankton, wasn't it? PLA something. Yeah, Plankton, yes. It's a really good name actually. I like that kind of wordplay. Then we are going to desolder our first PLA in a really long time. And this time, since it took so long time and since it was so difficult to get the solder out on this, I'm going to reflow these solder with fresh leaded solder so that I can make sure that it doesn't have the high melting point that the old solder have, because when you mix these in you are actually lowering the melting point. So on unleaded solder it's very wise to do this before you try to desolder anything with a desoldering gun or likewise. But on C64s, especially the 407 boards and also the 466 boards that I have never had a problem where I did have to add solder to all the pins. I do this occasionally to get enough suction if I have to redo a pin, but otherwise it has not made sense to do this. But this time, let's do it. I see here I have, I think, not lifted a pad, but it's one of these one of the pads actually, and this is have no connection on the underside. It actually loosened. I think one more. This actually is a great concern, and I don't know why the quality of this board is so much worse. There is actually a piece of a pad stuck to the tip of my desoldering gun, so I don't think we can call this entirely successful anyhow. Yeah, let's continue this with hot air, and yeah, hot air, and we are going to review this with the microscope afterwards. I just put in this, and I can also use the small needle I had. Yeah, there it's a needle. Yeah, I do have some spots here where we need to do some cleaning, and let's do that real quick. It's the same I saw as on the other one. You really can't suck out this solder either. Yeah, I do think we will be able to stick a socket in this now. But let's watch this through the microscope. Let's see how that looks. We might have to adjust a bit here, like so, and maybe a little less light. Oh, I think about so. This one was one of the ones we lifted. You can see here that all the copper is gone here, but it's not connected to anything underneath here. So this is the same, and this one, this can be bad. Oh, there is a blob of solder there still. Oh, this will be okay, but this one can be a problem. This one is not connected, not connected, not connected, and here you can see some more. And this one, here you have some. Yeah, these are not connected. I have to take it around too with the desoldering blade here. Oh. Yeah, I have no reason to believe that the guy that did this before me actually did anything wrong with what he did. So if I have made him sound bad, it's totally strange, because this part of the board, I desoldered this without lifting and disturbing a single pad, but here I've done a lot of havoc to this board, and I do hope that the board will recover. And this socket, I will take off this like so. This here is, I do need to have a machined socket in here, because I need to be able to see how the soldering actually go, and I might need to be able to go on the other side to check on my soldering. So this is going to be ugly, or maybe not. I did find one of my original setups. This is the kind of machine sockets that actually was first, and this is individual pins like so. They're just placed on this plastic thingy until I solder them in. So this is, yeah, I'm missing one here. I do have to go get another one. And with another one, I just mean this single pin, because I will be able to reuse everything else. Yeah, I will be able to solder this, and we will be able to straighten things out afterwards. But since this is not in any means, so the pins are connected to each other, it will be difficult to straighten out single pins afterwards. And here we have some pins that is not soldered at all, because they are missing. But I do think the vias inside are intact, so they should be able to drag some solder down in these holes. How does this look? This one, we have not been able to flow any solder at all down through the via. This one we sort of have. And these two also. But these two here, they are totally open. Let's see if that changed anything. Yeah, we was able to get some solder down in the via, and yeah, same on this side. So those should be okay. And when I lift this one, like so, these pins are standing now in the holes, and I need to turn this around and be able to solder the last one, because you can see one is broken off here. Sorry, I did forgot to. So you can see here I need to turn this around and take this one, because this was broken off. So I will just reapply this with the last pin and go in and solder that one. there are some that we need to solder from this side, and this is of course extremely difficult to capture on camera. This is the same operation I did last time to make sure that we had contact on both sides on the pads that was missing. So these sockets are quite good to actually do this, but it looks kind of strange, and they're also quite high, so they are lifting the socket a bit, or the chips away from the board quite a bit. Like so. I don't think we have any shorts, and it looks kind of strange, but I do think we have managed to sort this out just nicely. But the question remains. Let's dig in our fill here, and we do have a PLA, and it's desoldered, and here you can see one of the pads actually is fastened to one of the legs here. But MUS and not CIA, it was a PLA, and it was the 906114 PLA. (906114), yes, and okay. Minus jumper at position 14. And plus at 48. Ready to test. And so. And it passed. So the PLA passed the test, and they said that these PLAs could be marginal, but let's just for fun test this with another PLA, and then we will go on to do another test that I've been wanting to do. It's a bit hard to do this systematically because I'm trying to follow up on the tips I got, even though I'm not sure that every one of them makes sense, but some of them do, and the PLA was one of them that I actually thought it was worth trying, because I've always wondered what it is about this fascination about bad PLAs, as I've not encountered them myself. And we need some power. Yeah, black screen, no PLA, like it should be. And let's plug in a plankton. Yeah, it's kind of loose in this socket. And as we saw before, these planktons don't have this up, so I could actually, just by changing around the pins, not have used an extra pin for this. It actually looks a bit better. There are still some artifacts, but they might not be so bad. But let's, oh, there they are. They are back and they are bad. But let's just run through and see if the U1 error is still there. think it hang on us. This, no, it actually went through. Keyboard bad, control port bad. Let's see here. 65, 69, VIC2. Oh, sorry. Minus at 20. And 48 and 13. So one more wire. Well, it started testing without the chip in. Hopefully that won't come to a pass. Strange that it should go so long to test without the chip in. Failed all tests, yeah, that I would imagine that that is right. Then it's testing again, normal mode. Failed 3 tests, yes. I wonder if they write anything back on this memory stick to see what actually failed. Maybe we should check that. And yeah, we do have a text document here. What do we have here? This is the first CIA. This tested okay, and this was the one that tested bad, and this was the JCA. It failed on the IRQ3 test. Maybe it's some timer issue. And this was the first ceramic chip we tested, and so this one, and it passed. And this PLA passed, and the CIA passed. This was the real CIA we tested that we knew was okay. Or maybe this was the first one, and this is also a PLA. So all that we have tested is written there. And okay, hey, this is when we tested with this open. It failed all tests. And here we can see it failed 3 tests. Registers, IRQ, and lines. IRQ. We do have an issue still on this board. So I do think this is important here, because we do have these fails here. And we also, I will take off the desktop, we also have the failing PLA, not PLA but CIA to take into account. And what now if I put in this known good, also tested in this board, VIC2 chip. This gold-plated old revision one. Oh, it was crunchy in the socket. We can just, for fun, run the test again. I will turn on the capture, and as you can see, the screen looks totally fine, and this is with the HCT chip. It still measures the keyboard and stuff bad. We do know it was there before we desoldered this one. We do know that it was there after we desoldered these diodes. We do know that it was there even though we don't change this. We do know it was there even though we changed the PLA. And we also know that it was there regardless of what we did with this one. So should we take the schematics and look into that? To show you how these things are connected, I'm going into the schematics here for the, this motherboard, and it's a bit difficult to make do of all the different versions and revisions of the Commodore, but mostly the schematics are the same. I'm using simmers.net for this, and they have this to say about the 424 motherboard, and these are the two schematics that I find most suitable for this. And here you see that the U1 CIA, it's mostly connected in parallel to the U2, and you can also see the time of day clock is connected in parallel. You have these data lines, of course, are connected in parallel. You do have the address lines. It's these ones. You see here, so it's A. Yeah, they state here that it's A0 to A15, but that is not right. The CIAs only have these 4 address lines, and it's the same 4 that is connected here. And the chip decoding is done by the PLA. And the IRQ is a special case. It's only connected to U1. And remember, we did have an ERQ issue with the VIC2 chip that we took out, with the one with the 3 faults. So this could be something. And the read-write is in parallel. And the same with the reset. Chip select is of course unique for both of these chips, and it's CIA1 and CIA2. So these are the CIA1 chip select signal. And otherwise they are connected here to this 4066, and this is the pot X and pot Y that is going to the SID chip. The SID chip do have these inputs that handle these analog signals, and the 4066 is an analog switch, and of course it can be making some havoc. And I also think maybe that, I'm not sure what to think of this, but if you follow up on these lines here, you do have these connected like so here for the PA6, PA7. They are going up to the 4066. This has to be interleaved with the keyboard decoding. So this U28 can be the culprit. Otherwise we can measure out between all the legs on these to see if they are connected to each other, and that I mean the pin 26, 27, 28, 29, 30, 31, 32, 33, 35, 36, 37, 38, 25, 20, I'm not sure what the number here is, reset 20, I can't read this, and read-write 22, and this should of course not be connected to the same. But the problem we are facing is that we get something wrong on the test cartridge on the CIA, but we don't actually know what actually is wrong in this case. We do know that the keyboard is working, and what more do we know? Actually, we don't know nothing more than this CIA test out wonderfully in our chip tester. And here you can see they have tried to solder in these protection diodes, but these are already included in the circuit in this newer board. As an afterthought, I might see that this might not be the case, because this probably was the first board where this was incorporated, and I might think that the diodes we are seeing here is actually the original way of implementing this before it was ingrained into the PCB itself, because I can't find diodes otherwise that should match up with this. So then we are just going to measure out that these are connected. The address and data lines and all the control lines are connected as they should between the two CIAs. And then I'm probably going to desolder the U28 4066 to see if this behaves in such a way that it can make things happen here. So the strange thing in this board, we probably have two faults. They might be interconnected, I'm not sure, but the marginally VIC2 chip and the faulty CIA chip is not the same fault, that's for sure. I have taken out this 4066 chip, and just to test, and also to have something more to test in the Backbit ChipTester. I don't know how much you can see this screen, but I'm just going to choose it manually here, 4066, like so. Minus at position 7 and plus at, and finally the moron remembers to take out the old chip from the socket. Might have to reevaluate this. Minus at position 7. Oh, okay. Failed all test. I was pushing too much. It was no more leads than this one. So passed all test. But let's test our board and see how it behaves for future reference. I do have some entanglement of cables here. I'm just going to free all these. And just for future reference, just see how it checks if there is no connection at all with the 4066. And by the way, I have not measured out the 6526, the connections. And video signal in like so. And like so. Yeah, it started okay. And diagnostic. There we do have the distorted picture. I do think that's just an issue with this loosey SCART to HDMI converter I have. But now the issue is to see how this test and the SID test will behave when the 4066 is not in the board. Sorry, I was speaking over the SID sound test, so I didn't speak very clear. Now it says that the SID chip is bad, but it doesn't say anything about the keyboard, but it still withheld the control port as bad, as it should be when the X and E potentiometers are gone. And I will try to replace this 4066 with a known good one. And here I have a known good one from our scrap board, the board that we repaired. like so, and just test again. It still says that the control port is bad, but no, it's the CII's fault and not the SID chips. So there is an issue here, but the keyboard is now actually testing okay. I wonder when that happened. I didn't notice actually when it happened and what we did when it happened. But I'm going to test two more things. What this will say without the SID chip. And again, there it is, the video sync. Yeah, it does say the control port is bad, and it does do say that the SID is bad. What can be the issue with that? Let's replace some original junk in this board here. I will test this board with the JOD CIA. That we for in fact knows tests bad in the chip tester, like so, and I will put back the original, and this, and we do have to adjust the legs. It is a machined socket, so I will be able to get the pins in, but I might have to adjust if there is some solder blobs on them. And this also will be too wide. And this was my special socket without plastic. Like so. And so. There is the original PLA. I will put in another SID chip, and I will first test with this SID chip. Yes, what will we test next? What was my plan here? Yes, it was to test with another. No, it was to actually test the connections between these two chips to see that they are evenly connected. That was my next plan. And I do have my fish and chips chart here. That will tell me what to measure. This is the ports. They are not. And this is the PC. I'm not sure, but this pin should probably be connected to the other one. And it is. And time of day clock should be connected. The ground wire should be connected, and VCC should of course be connected. So that is okay. And on the next side, almost everything should be connected in parallel. And this is the fourth pin. It's called flag. Flag, okay. So flag is not connected. I have to check in the schematics. And IRQ is not connected. If I switch to the schematics here, okay, IRQ21. It don't seem to be connected at all on the secondary, so that is probably okay. And the flag, it's connected straight out. Yeah, it's connected to 5 volt and it's straight going to the user port. And flag is pin 29. Flag is 29, or is it 24? It states it there. And it's not connected here. Yes, it is there up. It goes to the cassette read signal. So cassette read is actually the flag. Yeah, so everything else checks out. I do have the right connections. We have checked the ports on this user ports. We have checked, we have these plugs in and out so many times that is not oxidation or anything, and mainly the user port is associated with, yeah, but control port. Yeah, I seem to be hung up in the term control port. I did mix it up with the user port in my head for quite a while here, but of course the user port is the joystick ports. And I will just switch to another diagnostic cartridge to make sure that there is not some incompatibility between this harness and the diagnostic. So I will just check with my other diagnostic cartridge and check what the result will be. And as we can see, it's exactly the same. But there are some long traces going from the user, the CIA, and over to the control ports. And control ports is of course the joystick ports. I was confusing them with the user port at some time here, but what about the joystick ports? I will show you this on camera. This is some stupid shit from my part. I don't know if I can show you, but if I do it like so and try to put this focus like so, you can see here that pin 2 in both of these are pushed in. How this did happen, I don't know. It's not something I can see that is wrong with my test leads. I will just change the focus back. I think this should be okay. And how do I fix that? I don't know if they are broken or if they just have been pushed back. I don't think they have been pushed back. I would have noticed that here. Okay, joystick port. What is... Check this out. This is pictures of the... yeah, it's the downwards. That is pin 2. How did I not notice this? Yeah, how do I fix this? I can of course downgrade this to the scrapboard, but I don't want to do that either. But Should I take and just desolder these? And if I do have some other non-totally compatible parts of this, I do think that most sockets will stay well within the C64 realm, so they're not this big. But yeah, just let's desolder them. And here again I am having trouble with melting the solder, so I'm going to try to apply some flux to see if that helps. And I lost the footage for this, but this is what actually happened. I desoldered from the top and I used only hot air after I've used the desoldering wick, and this only fell out by its own force. And you can see here what happened. One of the traces actually ripped straight off the board. So this board, extremely poor quality. I have never seen anything like it on a C64. And I will try to repair this just for fun, but at this point I rather think it's better to just take all the components and make a replace board. But I do have now lots and lots of C64, so I've kind of lost it with this one, and it was this one. Try to pull this and check what's going on with this. It's broken clean off. So how did that happen? I'm not sure. Is this repairable? Of course everything is repairable. In case it's not totally clear what I'm trying to do here, I'm straightening out this this pin, and I try to make it long enough and then make a new bend. So I only straighten it out and I'm pushing it into the existing hole and check that it's long enough on the other side, and I bend it and try to mend it this way, and then I will solder the bent piece down to the PCB, either via an extension or just I have to put a wire up through it. So that's what I'm trying to do, and I do think it will work. The strange thing that is exactly the same with the other one. So what kind of joystick or other trickery he has been using on this to get this result, I really don't know, and I can't even speculate. But for this to actually work, and it's this inner pin here that has suffered this one, so I do need to find a way to make this pin, and this is it's pin 9 there, where the trace is ripped completely off. All the other ones, they have survived. So can we get this back in? Yeah, I suppose so. I'm just soldering it in like so, and I have to fix the pin 9 afterwards. And this one does not reach through, of course. Yeah, the pin that I bent and put into shape is just raising the top of the PCB. So I'm just, for the sake of it, just soldering it through the PCB from the top, or to the PCB from the top, not through. It's just entering the hole, it's not passing through the hole. Like so, and then it was pin 9, and it's this that is closest to here, and can I make this connection on this trace here? Yeah, I'm just doing a really bodging repair here. I'm scraping off the solder mask on this very thin wire, and I'm just going to solder a wire wrap lead, also a very thin lead, to this, and see if I can make it stick. At this point this board is, yeah, I think it's scrap anyway, but I need to get it fixed to make sure that every component on this board works. Yeah, there is no holes or other place I can take this in, and I see here now it's almost impossible to get to this to solder this so it make contacts. So this board will of course never be useful in any way, and we do have this shield here that is going on top here, and if I put this wire through this gap, it probably will, yeah, maybe it will short out things, maybe it won't. But I do think the best bet is to just make the ugliest botch ever. Just to have it tested. And 9 is this one. That was one. For the other pin here, I'm not sure I will bother to solder this out. I do actually think that with all the damage that is done to this board, the best thing to do is try to cut this off and just try to bend it out. This AliExpress side cutter will never be the same again, but then again, my son has already destroyed it by cutting the wheel axles on some Hot Wheels toy cars. I'm just taking the pin now, I cut it, and I will just try to push it this way. I was able to do that on the other one. Let's see how far that got me. I need it a bit more. Oh! I bent it again, not good. This will break if I bend it too much, of course. A little bit more. There, I think. Yeah, that will do. Now you can see I do have a small piece here and I do have a small piece there. So I will try to desolder. It will be this one, and see if I can get this this pin out. That should be out, and then it's just about connecting a wire through that hole and solder it up there. I take this leg from a resistor. I'm making this small hook in the end to be able to put this over the pin that is sticking out. That is the rest of the pin that is sticking out of the 9-pin DIN after I cut it and bend it in place. Yeah, and temporarily I just bend it under the board so it won't fall off when I solder. Let's see if I can solder that in some fashion. Yeah, that's okay. And see if I have a pad to solder on here. Like so. And like so. And we're back to testing again. Like so. And port 1, port 2. So the thing I got confused about was I was thinking user port and control port instead of joystick ports. Of course, led me astray here for quite a while. And this board has not been the clear winner. Like so. Just had up this. Just let the test run. Yes, finally. Yeah. So now we do have a fully working board, at least. We will keep the diagnostics in. I will change this back to the CIA chip that originally was on the board. So that, and I will change back to the original VIC2 chip that we know for a fact tests bad on the chip tester. Somebody would have told this moron that it's not okay to change two things at once when you are doing fault finding. It's not a wise move. And the reason I'm moving this so carefully is that this is a ceramic piece. I won't risk to break it. Just have our reserves here. We have the CIA here. And I do have the OK CIA also here. Just keep them underway. And what do we test now? We are going to put back this one. And we are going to look into if we can make this. This chip is as we have detected marginally working. As we saw last time with changing the 373s, we was able to have it working better. I don't remember exactly what we was deciding, but this is the F chip, and this was one of them that was working best last time. And as you can see, it is kind of working okay. The picture is stable. It's nothing. The picture is actually better with this one than it was with the ceramic R1, and it's nice and stable with the F chip. So will this last? I'm not sure, but we need to test if everything is working okay first. Oh, keyboard open, yeah, of course. I will test with again with the keyboard connected like so. We anyway need to do some more burn-in test stuff on this to make sure that it's stable with this chip, and I will also put on some cooling on this one to keep it cold, but anyway I will try to test it as it gets more hot, of course. But if this is marginal, we don't want it to burn out anyway. And we're back where we started. Bad keyboard and bad control port. Oof. How did this happen? Is this chip so marginally that it actually will affect the address or data bus in such a way that it actually affects the keyboard? This is just my capturing device that comes. I've seen it, the flash that is striking to my screen is that C-cam, so it's actually detecting the composite video as C-cam. Now I'm just testing again after reseating the keyboard connector thingy from the harness. Control port bad. The bodge wire seems to still be in place. The pins are just doing nice here. It's nothing wrong with them. And I will try. I will leave everything else as it is. I just changed this VIC-2 chip back to the ceramic one and see if the control port and keyboard thingy comes back. Yes, the 83 version. It's also working like a charm with the F version. The F I actually do have from some PC project way back in the day. Yeah, I'm just fast forwarding to the test here, and as you can see, the control port, joystick ports, serial port, everything is working okay here. So I do think that we can conclude with we are not going to make this computer work with the original VIC-2 chip. But I still want to do some measurements, and I probably should have done this long time ago, but I want to check the voltages again, because I did check that I had something like 5 volt, but I will check again, because some of this is so inconsistent and that this chip is not stable. This chip is stable, but the other chip is not stable. Might have something to do with the voltages. Yeah, I've disconnected the harness as it can make some unpredictable results when I'm measuring stuff. And I've also put on a heatsink on the VIC-2 chip. I'm going to use my trusty power supply, and this is a rebuilt power supply with a switch mount regulator on a normal foot warmer brick. This is not optimal. It's 4.3 volt when I'm measuring over this IC, and the power supply itself is delivering about 4.9 volt to the power connector. And it can deliver a bit more if it's low power draw, but about 4.9 volt. So this is way too much loss somewhere here. Yeah, 4.3 volt, I measured that over the IC that we had fixed the traces on, so I'm going to measure over a decoupling cap, and here you can see 4.34, so it's the same. Yeah, I'm just going to disconnect the power, and I'm just going to exercise the power button a bit to make sure that there is no corrosion that is lingering here, and I just do that by switching this repeatedly. Yeah, let's connect the power again and see if that made any difference. Normally it would do. We also could exercise the plug itself a bit, but let's measure now and see what we got. Yeah, first we measure without any load and the power switched off, and that is 5 volt, so that is as it should be. The original power delivers about 5.1 volt. And about 4.9 with the switch turned off is also like it should be. It's well within spec. Yeah, so let's measure what we do have on an IC now. And yeah, that's much better. Just about 4.7 volt, and that is more than enough for this to be stable. But I'm going to check out what kind of resistance I do have in the power switch to see if there is any improvements to be made. Yeah, at first I'm measuring 1.5 ohms, but when I push it a bit into the solder, I get a result about 1.1 at the best, and the answer is probably about 1 ohm, and that is still pretty much. If I do have about 700 milliamps draw here, I will have 0.7 volt, and that is about what we measured earlier. So cleanly we have to clean this switch a bit. And that is not so easy. This is the switch with the metal switch switching mechanism, and I do have to take off the head, and that's quite easy in the switch itself. But I do have to use some deoxide or something and try to drip it into the mechanism because it's quite closed, and I don't want to disassemble. I have to desolder it and then disassemble it. It's a lot of work for this scrap board. Yeah, so with the rocker off, I will try to just make some deoxide drip into this mechanism. Yeah, I'm just using some run-of-the-mill deoxidation from Biltema. Oops, I see that my camera is way out of focus. I will try to adjust it. Yeah, here you can also catch a glimpse of my joystick port repair. Yeah, that's better. Now it's possible to see. I just try to get as much as possible of this cleaner down through the head of the switch. And some of it will leak in, and this will evaporate over time, but hopefully I will be able to fill this with this deoxider thingy. Yeah, and the worst YouTube filmer ever is adjusting the focus for you to be able to see, and then he keeps the whole procedure out of the picture. What a moron. Yeah, let's see what we are able to measure here. I take this meter on ohm and measure the same way as I did before. I put this here and I have the switch on, and I measure to the back of the switch and through the switch. And now you can see it's no resistance at all in this switch. 0.1, 0.21, and 0.1 is probably what I have in my measurement leads. So if I connect this up to power and turn it, I can first check with 506 with open circuit, and now it's draining power 4.85, a bit low, but that's the input we have. And if I measure on the switch, 4.73, 4.79. So I do have 0.0 something volt over this, and this is what we measure on the output of the switch. And if I now try to measure over this IC, 4.71. So now everything starts to look like it's on spec. I will try to test this now with the same setup as I did before to see if it's fixed anything. yeah, I have to connect up the harness. Yeah, I feel like I've been putting on this harness at least 100 times on this board, and hopefully we will get a result that is at least as good as it was before. And I did drop the heatsink on the VIC-2 chip. The glue actually fell off, so I have to buy some thermal tape to be able to get this to stick. Yeah, I don't have any high hopes to get another result, but this might explain some of the inconsistency we had with different 373 chips. But I'm getting really bored of this board now. I'm not going to do anything else here, and we can see it failed. So, no more work on this board. This has been a really long one, and I've taken this far further than I really should. The fault on this is obvious. It's this VIC-2 chip, and I have made this board work with another VIC-2 chip. I was just curious to see what actually was wrong and what made this VIC-2 chip work better with other 74333 chips. And now it gives a good picture with an F version of a 373, while others version don't work as good. And I've been tinkering with things, and I've been measuring around the chip to figure out what's wrong. But of course it is something with driving. It's about one of the inputs or outputs of this VIC-2 chip is getting marginal. And we saw the same when we was tinkering with the Celeron chip that has a bad driver that we have to make an external hook up network to be able to make the output transistors drive the logical levels. And it's probably something along the same lines, but I've dug very deep into this now. I'm not going to take this further. And this has been a really long video, and excuse me again because of the poor picture quality. I will again review my setup to see what I'm going to do, and I'm probably going to go this way. I'm probably going to use my GoPro camera as my new overhead camera to film stuff. Because I do have issues with lighting, I do have issues with syncing. Some cameras sync fine with one light. If I take on this overhead light, some cameras work. And if I take this overhead light, some cameras work. So there is no consistency in this, and if I'm going to have a multiple camera setup, I need to know that everything is working, yeah, together as it should. The new capturing device with capturing the signals from the composite video into HDMI and into the computer, it works much better than my previous setup with just filming off the screen. So this is good. And yeah, I'm going to review my whole setup before I make another video. So hope you stuck with me. At least I hope some of you did till the end. This was really a long one, and it's not the best quality, but I did think we learned something. So thanks for watching. Please like and subscribe, and hope to see you again in a future video. Thank you.